Welcome to section 1.7. Today we're going to talk about exponents and the order of operations, and these are both terms that you may or may not have heard before, but we're going to go over them. There are some key words involved here, like base and exponent. Maybe you've heard someone say something about a number being squared or cubed, and then what happens after that. And then what about the order of operations? So we'll go right into it. The first thing we want to do is define what an exponent is. An exponent is a whole number that indicates how many times the base is to be used as a factor. Remember, factors are multipliers. Exponents indicate repeated multiplication. So let's look at some examples. Let's see. Let's look at A. 3 to the second power. That's how we say this. We say this 3 to the second power, 3 to the second power, or we can say 3 squared, because what we're doing is we're saying I'm going to use the base is 3 here. I'm going to use the 3 as a factor, as a multiplier. How many times? Well, as many times as the exponent tells me. Oh, excuse me. As many times as the exponent tells me. In this case, there's 2 3's multiplying. That's what 3 squared means, or 3 to the second power. And 3 times 3 is 9. Let's look at another example. 5 to the third power, or 5 cubed. 5 to the third power, or 5 cubed. And so what this means is 3 factors of 5. So 5 times 5 times 5. And 5 times 5 is, that's 25. Times another 5. Well, 5 quarters would be $1.25. So 5 times 25 is 125. And let's look at C. 2 to the fourth. Now, notice there's only one way to read this. 2 to the fourth power. We can't say 2, what would you even say? After squared, cubed. Well, squared, a square is in 2 dimensions, length and width. A cube is in 3 dimensions. So something in the 4th dimension, what does that look like? Well, we don't really experience a physical 4th dimension in the way that we experience the first 3 physical dimensions, and so we don't really have a cute little way to talk about it. We just say 2 to the 4th. But the pattern remains. The exponent, the 4 in this case, tells us how many factors of the base we have. So this is 2 times 2 times 2 times 2. 2 times 2 is 4 times 2 times 2. 4 times 2 is 8 times 2. And 8 times 2 is 16. So 2 to the 4th is 16. Okay, now sometimes exponents are 1. And any number with an exponent of 1, right? If, let's pick something here like that we know. Let's do 5. How about 5 to the 1, 5 to the 2, and 5 to the 3. So let's go backwards, actually, since we just did 5 cubed. So 5 cubed is 3 factors of 5 multiplied together, which we just figured out is 125. 5 squared, or 5 to the second power, is 2 factors of 5. Factor means multiplier, right? 5 times 5 is 25. And 5 to the first power is one factor of 5. Just 5, right? It doesn't change. And so anything to the first power or to the 1 is itself. Just like multiplying by 1. Now, what about the 0 exponent? This is an interesting case. So any number other than 0 that's raised to the 0 power is 1, which is to say that anything you raise to the 0 power, except for 0, will be a 1, will simplify to 1. Now, why is that the case? It's not necessarily the most intuitive thing. Maybe one of the best ways to think about it is that the ones place is the center of our number system. On the left of the ones, numbers get bigger, and on the right of the ones, numbers get smaller. And sure, you could say that for any place value, but the ones acts as the first place value, right? And so that's kind of why it's special. Now let's look at an example here. 10. Well, let's look at something like 10 cubed. 10 cubed is 10 times 10 times 10, which is 1,000. The connection here between the exponent and powers of 10, which is what this is, right? This is 10 to some power, is that you can write 10 to some power as a 1 with that many zeros after it. So in this case, 10 to the third is a 1 with 3 zeros after it. How about 10 to the second power? That's 10 times 10, or 100. 10 to the second power is a 1 with 2 zeros after it. How about 10 to the first power? That's just one factor of 10. So it's 10, or it's a 1 with 1 0 after it. So following that pattern, 10 to the 0, it's 1, or in other words, a 1 with no zeros after it. And so hopefully this sort of makes sense in the context of the fact that our number system is base 10, and whenever we raise something to the 0 power, we don't get 0, we get 1. So let's simplify some of these expressions. A, 5 to the first power is one factor of 5. B, 9 to the first power, one factor of 9. C, 4 to the 0 power, anything to the 0 power, as long as it's not 0, is 1. And D, 8 to the 0 power, is 1. It's 1 because there are no 4s, there are no factors of 8 in these answers, and so 0 is not actually the right way to think about this, right? 1 is the right way to think about the ones place being at the center of our number system. Okay, so we practiced with exponents so that we could talk about the order of operations. So here's what the order of operations says in a sense. It says, do the most powerful operations first. Well, what is the most basic operations we learned? We learned addition and subtraction. We learned that addition is the most fundamental operation, the idea of adding things, combining things together, and subtraction is its opposite. Okay, then we had multiplication and division, right? multiplication is repeated addition, and division is repeated subtraction. So they're related in that way. Division undoes multiplication. So multiplication is repeated addition, so it's more powerful. So that means multiplication and division, try that again, division, they outrank addition and subtraction because they're more powerful. Now, what's more powerful than multiplication and division? There's really only one operation that's more powerful, and we just learned about it. It's repeated multiplication, aka exponents. So that's the order of operations. We take care of everything with exponents, because that's the most powerful, that's repeated multiplication. Then we take care of everything with multiplication and division, because that's repeated addition and subtraction. And then we take care of all the addition and subtraction. And we do these from left to right, because we read from left to right. And so the things on the left get priority. Now there's only one exception to this rule, that we do things in order of power, which is that anything inside of grouping symbols, like parentheses, we will do first. So the only exception to this is grouping symbols that call your attention to do something first. So the grouping symbols are parentheses, brackets, braces, absolute value bars. We'll talk about what that is later. The fraction bar, right? We'll see that later on too. So all of these are different ways to group things. The first three are the ones that we're going to see most commonly. So these are the order of operations. We take care of exponents, then multiplication and division, then addition and subtraction, and the only exception to that is if something's in grouping symbols, and then it calls our attention to take care of that first. So let's go look at some examples. This is just in words, essentially what we just talked about. And you can see here, if there are any grouping symbols, then we take care of that first. Then we go on to exponents, then we do all our multiplication and division, and then we do all our addition and subtraction, and we make sure to do these left to right. Okay, so let's have a look at this problem here. Simplify. Now simplify, that's the direction you're going to get whenever you have an expression. Notice there's no equal sign here. It's just a string of numbers and operators and other related mathematical symbols that help us to understand the relationship between all the various characters. And what we're tasked with doing is to simplify. In other words, there's arithmetic here that we can do. 7 minus 1, for instance, or 2 times the quantity 7 minus 1, or 5 plus that thing. Those are all things we can actually do. So what we're going to do is we're going to follow the order of operations, which says, remember, do the most powerful operations first, from left to right, then the next most powerful, then the third most powerful, unless you have grouping symbols like parentheses, and do that first. So in this case, the very first thing I'm going to do is what's inside parentheses. So everything else will come down exactly how it is. And I'll do the arithmetic inside parentheses. 7 minus 1 is 6. Now, have I done everything inside parentheses? Yes. So then why are the parentheses still there? Because they're showing me multiplication. And so what do I have left? I actually don't have anything to do inside parentheses. Instead, I have multiplication and addition left. Well, which one's more powerful? Multiplication is more powerful, so I have to do that first. So the 5 plus is just going to have to hang out until I've resolved the multiplication. 2 times 6 is 12. Now I can get rid of the parentheses because they're not showing me something to do inside of grouping symbols, and they're not showing me multiplication to do. So I can get rid of them. Now I only have one operation left, so it seems pretty straightforward, but in terms of going in order, we're doing this last because it's addition. So 5 plus 12, 17. So that is the simplified version of this. All right, let's do one that's a little bit more difficult. 9 times 2 cubed plus 36 divided by 3 squared minus 8. The first thing we want to look for, any parentheses, grouping symbols, brackets. I don't see any, so I'm on to my next step, which is to go in the order of the most powerful operations first. And in this case, exponents are the most powerful operations. So the first thing I'm going to do is take care of my exponents, right? Exponents first. So that's 9 times something, right? Plus 36 divided by something minus 8. And so instead of 2 cubed and 3 squared, I'm going to evaluate these and replace them with what they actually simplify to. So 2 cubed is 2 times 2 times 2. So 2 times 2 is 4, times another 2 is 8. And 3 squared is 3 times 3. 3 times 3 is 9. So 2 cubed is 8, 3 squared is 9. So I've taken care of all my exponents. Now I'm going to move on to take care of multiplication and division from left to right. So over here on the left, I'm cruising along and I see 9 times 8. So before I do anything else, I've got to take care of that. 9 times 8 is 72, plus 36 divided by 9 minus 8. All right, I'm cruising along here. I see 72 plus 36. That's addition, so I'm not ready for that because I've got multiplication and division to do first. I see division on over here, 36 divided by 9. Okay, perfect. I see that division. I've got to do that. So it's 72 plus, what's 36 divided by 9? That's 4 minus 8. Should I do 4 minus 8 right now? No, I have to go from left to right when I do addition and subtraction. So I'm going to go back to the left, like a typewriter here, and I'm going to look at the left. 72 plus 4, and that's 76 minus 8. 76 minus 8, it's going to be 68. So 68 is the simplified form of that. Simplify means repackage it into a single number if you can. And in this case, we were able to. All right, let's do a couple more. In this one, we have multiple grouping symbols. So what are we going to do? We have to start with the innermost. And so I see brackets, but I also see parentheses. So I'm going to go into those parentheses. I'm going to go in here. And that's the work I'm going to start with on the inside. So all of this is going to stay the same. And what is 5 minus 2? That's 3. Now, am I done inside my parentheses? Yeah, I've done everything I can do inside parentheses. So what are these parentheses showing me then? Why are they there? They're multiplication parentheses now. They're showing me that I also had to multiply this thing before I was done. So I'm still inside these brackets. What comes first, subtraction or multiplication? Multiplication is more powerful. So 3 plus 2 brackets, 10 minus 3 times 3, that's 9. Keep my bracket. Now I'm not done inside brackets. I got to keep going until I'm all done. So 3 plus 2 brackets, 10 minus 9, that's 1. Close bracket. Now, why do I still have those brackets? I did everything inside brackets. I got it down to a 1. Because they're showing me multiplication here. So I've got to do that multiplication first before I do the addition. So 2 times 1 is 2. Now I can add, that's 5. Okay, so here are some of the ways you might hear and see multiplication and division, addition, subtraction in a mathematical expression. So let's go through some of these. So 5 times the sum of 3 and 8. So 5 times the sum, so that means 5 multiplied by whatever you get when you add 3 and 8. So you've got to add 3 and 8 first and then multiply. And that's what the parentheses are helping us to see, that I have to add first. Same with twice the difference of 4 and 3. I double the difference, but I have to find the difference first before I can double it. And the parentheses help me to know that even though multiplication is more powerful than subtraction, it doesn't get to go first because of the grouping symbols. And that's the way I said it, and that's the way I wrote it. Okay. So let's review some of the key concepts here in this section. Practicing the order of operations is very important, and it's something that you will keep practicing throughout your math career, and it'll keep coming up. And so let's go over these key concepts. Take a second, answer these yourself, and then we'll come back to the video. All right, let's look at A. What is an exponent? An exponent is a whole number that indicates how many factors of a base are to be multiplied. And so in the case of something like 2 to the third power, or 2 to the exponent of 3, sometimes people will say 2 cubed, 2 times 2 times 2. The 3, the exponent, indicates how many, 1, 2, 3, how many factors, multipliers, of a base are to be multiplied together. All right. How about part B? Give a written description of how you would use the order of operations to simplify the expression 3 plus 4 times the quantity 5 plus 6. So what I would do is say add 5 and 6 inside parentheses, right? So add inside parentheses. That would be step 1. Step 2 would be to multiply, right? Multiply so you add the 5 and the 6, then you multiply the 4 times the result. 5 and 6 is 11, so 4 times 11 is 44. And then you add the 3 to that. So multiply 4 times 11, and then add 3. And so that's how I would describe it in words. All right, part C. What happens when you use 0 as an exponent? The result is 1. All right, and D. Name the 4 steps in the order of operations. So do what's inside the grouping symbols. That's step number 1. Step number 2 is evaluate any exponents. Step number 3 is to multiply or divide from left to right. And step 4 is to add or subtract, also from left to right. That's super important that these two go left to right. All right, so hopefully that answered some of your questions about exponents and the order of operations. Take a look at the homework in 1.7 and let me know if you have any questions, and we'll see you back for the next video.